Hello, this is Justin from Lesser Dog Tutorials, and welcome to part 3 in our point-and-click adventure game tutorial series, all about interactions. So let's jump in. Open the Adventure Cam blueprint, and open the Get Camera Confines macro. We're going to make a little bit of a fix. In the lower vector minus vector node, we don't have X and Y hooked up, we have Y and Z hooked up. So the X should be where the Y is, and the Y should be where the Z is. So the second thing I want to do is recalculate how we find the height of the screen. So from the camera, pull out and get the aspect ratio node. And what we're going to do is divide the ortho width by the aspect ratio. And then connect that up to be divided by 2 instead of 3.5, which was what it was before. Now we're going to set up the camera so that it actually follows the player. So we can delete the comment we made earlier for get player. And now we can add a get player pawn node. And from the return value, we'll cast to our adventure character. And you can connect that up to the delay. Next, create a new variable for the player and make the variable type the adventure character. And we can set that right after we cast to the character. Next, delete the bottom comment, and we'll create a new macro that we're going to call camFollowPlayerX. And we can add the in and out exec pins. And then we should duplicate the camFollowPlayerX and just name this one camFollowPlayerY. And you can duplicate it again, and we'll call this lerp within confines. And we'll go ahead and duplicate one more, and we'll call this set camera location. Back in the event graph, we can just drag these in the order in which they will be functioning. Right now they have nothing in them, but we can just do this first so that we don't have to come back to it. So first is the follow player X, then the follow player Y, then we make sure that's slurping within the confines, and then we will finally set the camera's location. So one by one, we'll go through and we'll set up the logic that goes inside them. And for the cam follow player X, which will be a lot like the Y, drag in the player reference, and from that, we'll get the capsule component, which you can usually find at the bottom of the list. And then from that capsule component, we want to get the world location. And be sure to split the struct pin for the vector. And then drag in the camera reference, and we'll get the socket location for this. And again, we will split the struct pin so that we can see the X, Y, and Z values. Now add the finterp2 node, and we're going to be interpolating from the X location of the camera to the X location of the capsule using our delta seconds variable. And for the interp speed, we'll set it to 12. Now add another variable that we will call current cam lerping position X. And make sure that that is a float. And then we'll drag that in and set it based on the result of the finterp2 node. And now you can select everything, and we're going to copy it and paste it over into the Y, camFollowPlayerY function. And be sure to change the X hookups to the Y ones. And then we can duplicate the cam lerping position X and just rename it Y, and do the same thing by setting it with the return value of the finterp2 node. Okay, those two are done. So now we can move on to the lerp within confines. Just to make sure, this is just to make sure that the camera stays within the bounds of the confining box. So create a variable that we'll call camera X and then another one called camera Y, both floats. And these are going to be the result of making sure that the camera is within the confines but still following the player. And we will use these to set the location of the actual camera. So in order to make sure that the camera is inside the confines, we'll need to use a clamp. So look for the clamp float node. And then you can drag in the lerping position X, and that will be the value. And then confine min X, and that's the min. And then confine max X, and that's the max. The result of this, we will set the camera X value to. So you can copy and paste that and then replace the variables with the Y counterparts. And then hook them up to the set floats. And that's really all this function is going to do. So after compiling and saving, we can move over to the last macro, which is going to be the set camera location. And really all we're going to be doing is assigning the position of the camera based on the camera X and camera Y values. So bring in a set world location for the camera itself. Hook that up to the input and the output. And then for the location, we're going to need to make a vector, which you can find near the top. The return value will go into the new location, and the X, Y, and Z values need to be determined. So the camera's Z value is what we'll be using for the Z. So if you get the world location for the camera, you can just drag from the Z to the Z in the make vector node, and then the camera X goes into the X, camera Y goes into the Y. And that should be all we need to do for the camera to actually follow the player. What I'm going to do real quick, though, is just organize some of these variables because there's a lot of floats, and we want to make sure that things aren't too confusing for anything we may need to do down the line. So I just made a cam confine group, and I put the confining variables in there, and then the cam location group holds all variables associated with moving the camera. All right, let's test it out. All right, it looks like the camera is following and it's stopping at the edges. So that is a success. All right, everything seems to be working fine, except when you close the game, there's an error. And this is because when it's using the player variable that we made, it's doing it on tick. And there is going to be some frames when the player isn't actually assigned yet. So what we want to do is put an isValid node in between the tick and the macros we made, just to make sure that the player exists in our variable. Because if it doesn't, we don't want it to continue and do anything. But if it does exist, that's when we want to follow. So having made that change, if you play, it works just like before, but when you close it, there aren't any errors. Cool. So let's get into this interaction stuff. Open up the WBP Verbs blueprint and head over to the graph, and you can remove everything except for the event construct for now. And then create a new variable that we will call close normal style. Change the variable type to a button style and duplicate it and name this one close selected style. For the normal style, we don't need to do anything. We just need to have the variable. But for the selected style, we want to change the normal, hovered, and pressed images to the corresponding highlighted image. And go ahead and create these two variables for each of the 9 buttons. And a little tip to make things faster, you can right-click a style, copy it, and then right-click the other two and paste the same style over them. So then you don't have to hunt for the correct image for all three. So go ahead and pause the video and get that done, and I'll be here waiting for you to be finished. Welcome back. Good job. Man, you really went fast. So create a macro called assign normal styles. Then be sure to add your in and out exec pins. And you can drag this into the event graph right after event construct and link that up. And then in here, what we'll be doing is adding a sequence node. And you want to add enough pins for each of the buttons. So it should say then 8 as the last one, so 9 total pins. And then we're going to be dragging in each of the normal styles to set. You can hold Alt as you drag for a shortcut. Then I like to select all the nodes and align them. Align left actually looks pretty good. And then I distribute them vertically so that they're even, because I'm anal like that. And then connect each one up to the corresponding sequence pin. And then I like to kind of organize things so that they are, the lines are out of the way. And then at the last set style is where I go to the out. Then you can drag in each of the button styles, and from each button we're going to be getting the style and connecting it up to the set button style nodes. So all we're really doing is getting the current style of the button and assigning it for later use. Now let's make a new macro that we're going to call set clicked style and add the in and out exec pins. And we'll just save this for later. Next, create a new function that we're going to call clear selection. And all this is going to do is assign the normal button styles to all of the buttons. So if you drag in a button, and then from the button you drag out, search for set style. And then you just need to link up one of these for each button. So a quick copy paste. Make sure that there's 9 of them. And then go ahead and drag in each of the buttons and assign it up to the target input. By the way, has anyone told you you're doing a great job? Well, I'm not, because I can't see what you're doing, but I hope you're doing a good job. Now create a new macro, and we're going to call it set active verb, and make sure you add the in and out exec pins. And then we're going to add a second input, but we need a new enum, an enumeration, to determine which verb we'll be using. So in the blueprints folder, create a new enumeration called enum_verb used. So in the enumeration, we're going to create actually 10 entries, not 9, because the first one will be walk to. We want this one to be the first one just because it'll be the default. And then make sure you put the correct verbs in each of them, which are give, open, close, pick up, look at, talk to, use, push, and pull. All right, and then save that, and you can close it. And then back in our set active verb macro in the verbs widget blueprint, select the input and add the second input pin of type enum verb used. And you can call it verb, something simple. And then we'll head over to the clear selection function, and we'll drag in the set active verb at the end. After that, make sure that you're dragging in the normal styles for each button, and make sure that they're matching the button that you are assigning the normal style to. Now open the adventure controller, and the adventure controller at the end of this is going to be doing a lot of the player's interaction logic. But for now, what we'll be doing is creating a new function that we'll call assign verb, and then create a variable to hold that verb called active verb, and the type will be verb used. Then for the input, add another input called verb of type verb used, and use it to set the active verb variable. Then back in the verbs widget blueprint, go to the set active verb, and then we're going to get the player controller, and from the return value, we'll cast to our adventure controller. And we will be running the function assign verb from here and passing in the verb from the input. So now we have a reference to the verb that is currently active. Back in the set clicked style macro, drag in the clear selection function and put that in right after the input. And then we're going to add 3 new parameters to the input node. And one will be the verb used, the other will be a button reference, and the third one will be a button style. Next, right-click and look for the set style for a button. And if you turn off context sensitive, it should be near the top. And just hook up the style to the in style and the target to the button. And then connect that up after the clear selection node. And then we'll want to go over to set active verb, and we'll just copy the nodes there and paste them in here. And we can hook that up at the end and then assign the verb to the verb input of assign verb. And then that can go to the output. Then back in the event graph, we're going to select each button and add the on-clicked event for each. And then each of these is going to run the set clicked style macro. Now you can just use the drop down to assign the correct verb for each of these functions. And then we will need to drag in the buttons for each and the selected style to the style. And then that will complete all the on-clicked events. So with that done, we can compile and save and test it out. And if you click each of these, it will stick. However, there is one issue with the push and pull. So if you head back over to the Verbs widget blueprint, then set the correct images for push and pull and change them from open and close. And there we go. So now it's working. You click one of the verbs, it will be selected. You click another verb, it will deselect the previous one and select the new one. And that's what we're looking for. So next, we'll want to create a new blueprint and search for AI controller and select that one. And we'll name this BP_AI adventure controller. And what this is going to do is actually control our player as opposed to how we were doing it before. So after that's made, open the normal adventure controller and create a new variable called HUD of type HUD, the one we made, WBP_HUD. And then compile and save that, and you can close that. And then in the adventure mode, we're going to be changing how this works a little bit. You can just drag the current nodes out a bit and disconnect them. And then from the get player controller, we're going to get the adventure controller. And then you can hook that up to the create widget blueprint. And then player controller can get connected to the owning player for that. And then from the adventure controller, create a reroute node and then drag out, and we're going to set the HUD, the variable we just made, using the HUD we just created. So just kind of put it in between add to viewport and the create HUD. Cool. So at the end, we're going to search for get actor of class, and in the actor class dropdown, look for the AI adventure controller we just made. And then add the get player pawn node, and from the return value, we'll get the adventure character by casting to it. And then take a second and we'll head over to the player controller again. We're going to add another variable that we will call player character. And just to have a reference of the player character is going to be useful. So make sure the type is adventure character. And then compile and save. And then back in the adventure mode, you can drag out from the player controller reference from earlier, and we'll set the player character from the cast we just did. And then at the very end, we will add a possess node, which you have to turn off context sensitive. And the AI adventure controller is the target, and the pawn is the player character. And now this will make the AI controller that we made earlier be the controlling controller for the player that we spawn. And this is because we're going to be using a move to using the navigation, and we want it to be much more exact than what the current player controller can do. So if we hit play, we'll look in our hierarchy for the AI controller, but it's not there. So we can't possess the player with it until we tell Unreal to use it. So if you open the adventure character and select the top level of the hierarchy, you can search on the right side for the pawn section and change the AI controller class to the one we just made, but also change the auto-possess AI from placed in world to placed in world or spawned. And if you hit play, the camera screwed up, but the AI adventure controller is in the hierarchy now, and that's what we want. Now head back to the adventure character and we're going to overhaul this thing. So in the functions, add a new function that we'll call set position. And then open the set player position macro, copy everything that's in there and paste it into this new function. Then we can remove the target player location variable that we're setting and just do a make vector because we don't need that reference anymore. And then hook up the X and the Y and the Z to it. Return value goes to the new location. And that's all we need to do here. Then we can replace the set player position macro with the function we just made. Next, delete everything else. We don't want it anymore in here. So you can delete the target player location variable, you can delete the mouse over UI, and then we can delete the simple move to location and just hook the event tick right up to is character moving. Cool. So next, head to your blueprint folder and we'll add a new blueprint. And it's going to be of the type static mesh actor. And we're going to call this one BP underscore hotspot. Next, we're going to create a blueprint interface, and that's in the blueprint menu section. And we'll call it BPI for blueprint interface underscore verb interaction. And so you can open that up, and what this does is it creates any number of functions that you want. And if you were to have some other blueprint implement this interface, then you can use these functions. So This is a way for us to have the same functions on all interactable objects, be it a character or a hotspot or an inventory item or something, that they all share the same functions. So create a function for each verb. So it would be on pickup, on give, on open, on close, on look at, on talk to, on use, on push, on pull, and save it. And then you want to go to the hotspot blueprint that we just made. And at the very top, you'll see the class settings button. And if you select that, you'll find a section called interfaces. If you add the verb interaction interface, we are now implementing the interface. And on the left side, you can see all of the functions that we just made. So head over to the event graph. You can delete everything. And then select the static mesh component and scroll down on the right side and see the event section. And you'll want to add on begin cursor over and on end cursor over. And if you right click on each of the functions on the interface section, you can select implement event, and we want all of them implemented. So if they're all implemented in the hotspot base class, then any sort of blueprint that we make based on this will have these functions already. And all we'll need to do is override the function if we want to do something unique for any specific hotspot. So just as a test, we're going to use print strings on all of these. And you can have them say whatever you want. But for instance, on my cursor over, I just have it print mouse over. And on end cursor over, I have it say mouse exit. And then I just duplicate them all and just connect them. And like I said, have it say whatever you want, just so you know it's working. So you could even just say on pickup for the pickup thing if you want. But in the end, what this is really going to do is have the character say default responses to things. So like if in your game you had a hotspot that was a car and you used pickup car, your character would walk over to it, and since it's so big it can't be picked up or whatever, you would do the default reaction, which would be found on this blueprint. But if you say made a cup and it was based off of the hotspot blueprint that we made, you could override the pickup event and then change it to whatever you want, where we could add a cup to the inventory. He could say, I think I'll just take this coffee cup or whatever you need. So this is how useful interfaces are. It allows you to do the same types of functions on various different types of objects. So to demonstrate this functionality, we can create a new blueprint that will be based off of hotspot, and we'll call this BP underscore hotspot underscore poster. And then in the poster event graph, we can go over to the functions, click override, and we can find all of the functions from the interaction interface. So we'll just override for now the look at function, and we'll just print a string specific to this, like looks like a poster to me. So when you look at the poster, it should override the one we created in the hotspot blueprint and become unique. But we need to do a whole lot of stuff before we can test it out. So over in the adventure controller, create a new function called mouse enter hotspot. And we'll want to add a new parameter on the input of type hotspot that we'll just call hotspot. And from there, we'll just do a print string, and you can just connect it to the hotspot to get the display name of the hotspot. And then create another function called mouse exit hotspot. And what this will do is just print another string that just notifies us that this is working. Cool. So we can remove in the hotspot blueprint, we can remove what is on the begin cursor over and end cursor over. And instead we'll get the player controller, and from that cast to the adventure controller and just run those functions that we just made. So we would enter the hotspot, and for the hotspot we would say self. And then for the end cursor over, we do the exit hotspot, and we don't need to link up any hotspots for that. Now we're going to make a few variables that will be visible in the editor so that we can edit these whenever we drag a hotspot in. So make a vector variable that will be called walk to position. Then create a string variable called hotspot description. And then we need one more variable called facing direction, but it needs to be of a type that we have not made yet. So we're going to make yet another enumeration, and we'll call that enum underscore facing direction. And this will just have 4 entries, each direction that the player can face. So up, right, down, and left. And then save that, and you can close it. And then back in the hotspot blueprint, we're going to change that facing direction variable type to the facing direction enum. And all of them must be visible. And then we're going to add a sphere collision component. We can set the sphere radius to 4. And then select the sphere and rename it to walk to point. And then head to the construction script. And we're going to add a set world location node for the walk to point. So you can drag the walk to point into the graph, drag from it, and look for set world location. And the location will be set to the walk to position vector variable that we made earlier. Next, select the static mesh component, and then in the details panel, if you scroll down to the collision area, we want to generate overlap events. So tick that box. And then look for rendering and hidden in game. Make sure that's checked. Now let's create a mesh for the poster. So we have that meshes folder, and switch the mode to brush editing. We have auto extrude, turn off convex polygons, and make the depth 4. And then click inside the screen here and use spacebar to create these points. Draw the shape around the poster, hit enter to finish it. And then over in the brush settings, we can create a static mesh, choose the meshes folder, and we'll rename this to poster. And now we have a poster mesh that we can use for a hotspot. So we also want to add a material to it that we make just to make it obvious. So create a material in your materials folder. We'll name this M underscore hotspot material. And if you open that up, it's nothing too complicated. We'll just change the shading model from default lit to unlit. And then we'll want to add a constant 3 vector node. You can drag that to the emissive color, and then in the details, we'll change it to a green, a bright green, and you can save that. And then next, we'll want to apply that material to the mesh. So if you double click the poster mesh, you can change the material to our hotspot material and save that. Then you can head back over to the hotspot poster blueprint, select the static mesh component, and then assign the static mesh to be the poster, which it now is green because that's the material we did. And then if you look at the top view on lit, you can see it looks exactly like the outline we made. And then if you drag the poster into the scene and line it up with the object and make sure that it's above the image. If you switch it to the left, you can see where the image is of the background. Just make sure it's above that. And now we have that hotspot in there. And then head over to the HUD. And we need to unhook these errors here. So just unhook the event tick for now. And then you can head back over to the main window. And before we can really test this out, because the camera's not working, we need to set up the rest of the functionality. So in the Adventure Cam blueprint, unhook everything except for the get camera confines on the event begin play, and then cut the nodes that were there, because we're going to paste them in the Adventure Character blueprint instead. So once it looks like this, head over to the Adventure Character, add the event begin play node, and then paste in the nodes we cut from the cam blueprint. And the order of hooking this stuff up, we want first to head to a delay of 0 seconds. And then we're going to drag in the capsule component, and from that, we'll get the overlapping actors. Class filter will look for the adventure cam. Drag out from overlapping actors and get a copy of 0. And then from that, we'll cast to the adventure cam. So we'll only be grabbing whatever cam is available. There should only ever be one. And then hook that up to the set view target with blend and make sure that the adventure cam is set up to the new view target and the player controller is the target. And then you can drag out from the adventure cam again, and we're going to set the player for the cam to self. And this is what it should look like. And then select the top of the hierarchy, and then we're going to uncheck use controller rotation yaw, because otherwise the player will rotate when it moves. Now we are going to go to the adventure controller and do a whole lot of stuff. So delete the event tick and just leave the event begin play, and then we'll add left mouse button event. And we're going to use this area to kind of do the left mouse button logic. So we'll add a macro called get clicked to determine what we're clicking. And we'll add the in and out pins and search for a node called get hit result under cursor by channel. And the hit result pin, you want to right click and split the struct. And find the hit result hit actor, and we'll cast to a hotspot. And that way, if it succeeds, that means we have a hotspot, and if it fails, we don't have one. So change the out exec pin to hotspot, and then add another exec pin called nothing, and hook up the cast node to those. Then we'll add a variable called target hotspot, change the type to BP hotspot, and we'll drag that in and we'll set it right after we cast to the hotspot just to keep a reference of the hotspot. Cool. You can compile and save, head back to the event graph and drag out the get clicked right after the left mouse button event. And then you could also use this on the released pin, but for now we'll just do pressed and see how it works. So add another macro that we'll call walk to hotspot. And this is if you click on the hotspot, we want to walk to the walk to location that we have already determined on the hotspot. So add another variable called hotspot interaction and make it a bool, just so that we know we are dealing with a hotspot. And don't forget to add the in and out exec pins. And the first thing you'll do is set that hotspot interaction to true, and then bring out the target hotspot. And we want to check if it's valid before continuing. It most likely will be, but it's better to check just in case. Then look for a node called move to location or actor, and this only works on AI controllers, which is why we made our character use an AI controller. So getting the player controller is not going to work in this scenario. So you need to take the player character out, drag from that, and say get AI controller, because that's what it's using. As you can see here in the adventure mode, this is when we possessed the target player with this controller. So you just need to hook up the return value to the controller, and now you can see the goal location is there. So what we want is from this target hotspot, we can get the walk to position and use that as our goal location. But we want to split it because we still want to use the Z location of the capsule component on the character and not the Z location on the target hotspot's walk to position. So we'll need to make a vector using the X and Y from the hotspot and the Z from the capsule component. So what the move to location or actor node does is it creates an async task which operates until finished or interrupted. So what we want to do is store that task on a variable that we'll call current path, and the type will be of AI task. And if you drag that out and set it right at the top exec pin, you can drag the async task to the current path to set it. But we're not going to go to the out. We're only going to go to the out after it's been finished. But we also want to fire an event to read later that an action is happening. So create an event dispatcher called begin action, drag it out, and we'll call it right after the current path is set. And that's going to come into play a little later. Back in the event graph, drag out the walk to hotspot, and from the get clicked macro, the hotspot pin, that's where we're connecting it. And then add another macro called set facing direction. So once the character arrives at the hotspot, we'll have them face the direction that we specify. And we'll add the in and out pins. Drag in the target hotspot, and from that, we're going to check if it's valid. And if it is valid, we want to reach the actual character itself and have it flip its sprite depending on which direction, if it's facing the to the left. So we'll add a function on the adventure character called set facing direction, and we'll just switch on the facing direction that we pass in. So we'll need to add an input parameter of type facing direction, and we'll just call it facing direction. And then you can hook that up, and depending on the side, we will be setting the animation state. So you can copy that and paste it 3 times, one for up, one for down, and the other one for the 2 sides. And then you can add the return node and hook these 3 nodes up to it. But the up will go up to the top one and change the animation state to idle up. The down will go to the next one and we'll set the animation state to idle down. And then right and left, we need to determine which way the sprite's facing. So drag the sprite in, look for set relative scale 3D, duplicate that. And then we'll set the output of these to go to the set animation state idle side. And we can change all of the numbers in both of these to 1, except the bottom one, which on X will say -1. And that one will be hooked up to the left facing direction, and the top one will be the right. So the only time we're setting the scale to -1 is if it's facing left. Then back in the adventure controller, we want to call that function we made. So drag in the player character, and from that we'll run the set facing direction, and we'll pass in the target hotspot's get facing direction into that facing direction parameter. And then we can connect that to the output. Cool, so after the walk to hotspot, we want to set the facing direction. And then we need to run whatever happens based on the hotspot and whatever interaction is chosen. So create a macro called perform interaction, add the ins and outs, like always. Bring in the active verb, and from that, we're going to switch on what verb has been used. So if you extend it, you can see all of the different verbs that we have. And then drag in the hotspot, and from that, we're going to run each of the functions that came from the interface. So all 9 of them are going to be ran here and hooked up to the corresponding verb used. But walk to will not have any of these functions, so that goes straight to the output. Otherwise, they all go to a function that we've already made on the hotspot. And then after all of these are set up and hooked up to the switch, we then pass them all to the output. So you can also distribute them vertically and align them left so they look nice. And then be sure to connect all of the exec pins. Cool. Compile and save that, and then we will drag that perform interaction right at the end. And then we'll create a new function called interrupt action. Should we ever need to stop an interaction that's in process, then we'll run this. So get the player character, drag out from it, and get the character movement. And then we're going to run a function called stop active movement. After that, we will set the verb to its default, which is walk to. Then we will set the target hotspot to nothing. And then we will set hotspot interaction to false. And then we'll create another event dispatcher called interrupting action. And we'll call that at the end. Cool. Compile and save. Now in the event graph, we can interrupt the action right at the end. Now we need to determine what happens if nothing is clicked. So we will add a function called clear current path. And the reason that it's a function is that we could call this from other sources. So drag in the current path, check if it's valid first. If it is valid, then we want to stop it. So if you drag out from the current path and you find a function called end task, that's what we're looking for. Next, we want to use the interrupt action function, and if it's not valid, it goes to this function, and after end task, it goes to the same function. And then we will return. Then we can drag in clear current path and start off the nothing chain with this. So now we need to walk to the location that we've clicked. So we'll make another macro called walk to location and add the in and out pins. And so we need to make a variable called isOverUI, which will be set using the HUD, but we will be doing that later. So we'll just say, if it's not over UI, which is going to be the case every time currently, then we'll move to location or actor again. And when it's finished, that's when we leave. But we will also set the current path again for this. It's something to be interrupted. Then we'll go ahead and get the player controller. And from that, we will convert mouse location to world space. We can split the struct of the world location, and from X, we'll get the floor, and from Y, we'll get the floor. And this, again, is only for pixel art games. So this is just going to lock the character where the pixels are. You don't need to do this if you're not doing a pixel art game. And then we're going to make a vector. And the goal location in the move to location or actor node is going to be whatever the return value of the make vector is again. And for the controller section, drag in the player character reference, and then from that, get the AI controller, and then drag in the player character again, get the capsule component, get the world location, split the return value, and drag Z into the Z of make vector. Sweet. So that should be now added to the end of the clear current path chain. And that should be all we need to do in the player controller. There's just one more thing that I think will really help. So go to the project settings, and over on the left side, you'll see the navigation system section. So click on that, and then you'll see the agents section, which is supported agents. And if you add an agent to this and you click the down arrow, you can select the new agent radius, and we'll just say it's 1 here. And then if you go to the world settings and scroll down and look for the navigation section, you can see default agent name. We'll just name this default, the same as the one we just created. And now I believe it's always going to say 1 for agent radius, and it won't reset like it's been doing. So hopefully that will fix the problems we've been having with that. Now select the poster hotspot and change the walk to position to wherever you want the character to walk. I'm going to pick the left a little bit here. And if we select the poster and walk to it, He stops at the spot he's supposed to, and the mouse over events are working. Everything appears to be working well. He's not facing the right direction. So, we need to change the facing direction to be right. Okay, let's test it out. He walks around. If I walk to the poster, yep, he turns to it. That's good. If I use the poster, he'll walk to it, turn, and say, I can't use that, which is exactly what we're looking for. Push it, and I interrupt. Look at, I'll interrupt it. Yeah, the interrupt appears to be working well too. So that's going to do it for this video. Thanks for watching. If you liked what you saw, please hit like, please subscribe, and I will see you in the next video. Thanks.